Okay, this is part 3, and it'll be the last part, and hopefully I keep it. I'm trying to keep it right at 10 minutes. This section is on fronts, and as a review, we've been talking about these air masses, and these air masses are not stationary in the sense that they move like animals. They migrate. And just like with people, some of these air masses often don't get along, and the polar air masses and the tropical air masses, as you can see here, their arrows kind of lead you to realize that they kind of collide in places, and they just don't collide. They move and push each other back and forth, north and south, with the jet stream as the jet stream moves north and south. So our goal here is to understand exactly how these air masses are moving, and by the end here I'm going to show you that today's weather on April 22nd, 2020 is actually being influenced as these air masses are affecting our weather today. So I actually have today's weather map up here. So I'm going to get back into the talk here and get back into getting into the fronts. And this is where we left off right here. Let's just go to war. That's what we're talking about. The whole terminology of fronts and all of the great movies like Saving Private Ryan or the movie 1917 or Midway. They're often dealing with the terminology from old warfare. Meteorology likes to use military terminology, and predicting the weather where we live is very much like understanding war. Just like we talked about, some of these air masses are like nations with armies, and they don't get along, and they want to fight and control for territory. And so we're going to discuss some of these fronts and the 4 different types, and then we'll look at a weather map to wrap up and show you how this all ties together with today's weather. We use symbology on weather maps with blue lines representing cold fronts, which is continental polar air. This means that on one side of this blue line is continental polar air, and generally on the other side, out in front of the blue line, is maritime tropical air. Then you have warm fronts, which means on either side of the line, behind the line is the maritime tropical air, and out in front of it is usually continental polar. And then we have 2 specialized kind of fronts called stationary and occluded, and I'll show you some examples of each. But they are almost always generally in the Midwest, dealing with the positioning and the movements of continental polar and maritime tropical air, as they're both competing and vying for territory over the Midwest of the United States. Cold fronts are environments where cold air from continental polar air is advancing into maritime tropical air. So generally along these environments, we see an advancing cold, dry air pushing down into the south. Cold air is pushing warm air out of the way and displacing it, and as it's displacing it, it's also lifting it. That's why along cold fronts, as cold fronts come into an area, we know they're going to bring colder, drier air, but before they actually get here, they're taking all the warm maritime tropical air out in front of them and actually throwing it and lifting it upwards. And that's why as a cold front is approaching, we often see a heavy line of cumulonimbus clouds or thunderstorms producing heavy precipitation out along a cold front. So cold fronts are often triggers as they come out of the northwest and push to the south, often southeast. They often are associated with, before they arrive, heavy thunderstorms, and then after they arrive, cooler, drier air displaces the warm air and conditions calm down. So this is what it looks like as a cross-section. Continental polar air is moving to the south. Maritime tropical air is out in front, and as the cold air is pushing and advancing into the maritime tropical air, not only is the maritime tropical air retreating back to the south, along the boundary of the advancing cold air, the maritime tropical air is being thrust upwards over the cold air, and that's where we see this beautiful line of clouds and rain forming, and that's why most fronts are associated with usually very cloudy, wet conditions. The only thing that changes is what type of clouds and what types of precipitation. Cold fronts are associated with very heavy, short, intense downpours with very fast-moving fronts and vertically developed clouds. On a weather map, we use tools like radar and satellite imagery, we can see how these new forms of technology over the last 20 to 30 years have rapidly given us new abilities to actually mark and identify where air masses and frontal positions are and how they change over time, which has led to radical changes in how we can predict and forecast weather. Warm fronts, on the other hand, come from different directions and have a completely different sort of pattern in terms of they move in different directions. And the one thing they have in common is they often produce clouds, and they often can produce rain, but they move very differently and they have different types of clouds associated with them. So what I want to show you is a cross-section of a warm front, and a warm front occurs when maritime tropical air is pushing to the north, trying to displace continental polar air. Warmer maritime tropical air is lighter, and it has a much harder time of pushing cold air out of the way. Sort of would be like a smaller, lighter person trying to push a heavier person backwards. They would have a hard time. So warm fronts travel fairly slow, and as the warm air pushes the cold air back towards Canada very slowly, the warm air also rides up and over the boundary of the retreating cold air, and as it does, you can see the maritime tropical air kind of gently rides up the slope of the retreating cold air, producing nice flat-like sheets of stratus clouds. These flat clouds often in areas will produce rain, but the rain moves in a very different way. It moves by very slowly, and the type of rain is usually a slow, steady drizzle. Nimbostratus clouds are much more stable clouds, and that's why both cold fronts and warm fronts produce rain, but they're very different types of rain, and warm front rains move by much slower and much more gently than typically cold front precipitation events. We will often see that cold fronts are the fronts that we often see triggering severe weather. Stationary and occluded fronts are basically occur in very specific, unique conditions where we have fronts that are actually best viewed by a graphic. And this occurs when we talk about in the next chapter, which is called a mid-latitude cyclone. With a mid-latitude cyclone, we actually see that cold fronts and warm fronts often travel together. And often cold fronts are trailing in behind warm fronts, and cold fronts can travel up to 30 to 50 miles an hour, and warm fronts maybe are often traveling 5 to 10. Recall, warm air has a very difficult time of pushing colder air out of the way, whereas cold air advancing into maritime tropical air has a much easier time. Stationary fronts occur when cold fronts over time catch up and actually lift all of the maritime tropical air up. And eventually the warm air is caught by the cold air, and effectively there is no more frontal differences. As the cold air has displaced and caught the warm air, you will often see the line, instead of having two separate lines, you'll have actually a purple line, which would indicate occlusion, meaning that a cold front has caught a warm front, and eventually that usually is the indication of the ending stages of what we call a mid-latitude cyclone, which will be discussed more in the next chapter. Now, and you can see here by this diagram, this is an indication of occlusion. As the cold front is catching, you can see that the cold front and warm front symbol are on the same lines and the same color. But notice during occlusion, just like with warm fronts and cold fronts, you do see that warm air is being lifted, and all fronts do have clouds and rainfall associated with them. It's just the types of clouds and the types of rain often do change. What I would advise you to do is I'm going to click through these slides here real quickly, and I'm going to go very quickly. These are all examples of occlusion. And that's the end of chapter 9. I wanted to speed this along, and I wanted to show you today's weather map to kind of wrap up this chapter as it is we're going along. Here is today's weather map, and you can see all over the weather map we have actually a stationary front that is actually passing by, and all these weather systems and lines are moving west to east, as you should know from Unit 3 with the westerlies. You could see how in central Illinois on Sunday afternoon we're on the back end of a stationary front that is pushing to the east, and very rapidly you could see that where the precipitation is occurring is always along these frontal boundaries. It's very interesting that we have a stationary front now to our east, high pressure in the middle of the country, and we have another line of fronts coming in out of the west. That's why we have forecast today. The clouds and rain are moving out as the fronts are moving away from us towards the east coast. We have high pressure setting in today and early tomorrow, but by Tuesday we have another frontal boundaries coming in with a warm front coming in and then a cold front trailing in behind it. This should start to mean something to you of why Sunday today our weather is going to be improving as the clouds and rains are leaving, as we're losing our frontal lifting. And we have high pressure setting in for a day and a half, but now we have some more frontal lifting coming in. So that's why we're going to go from overcast wet to clear skies for a few days, and then Tuesday afternoon, here's our next chance of rain coming in with these frontal boundaries coming in. So I would advise you all to go to YouTube and put in weather associated with fronts and really look at cold fronts, warm fronts, stationary fronts, and occluded fronts, and really look at some of the diagrams. There are so many good videos that experts have put on there, and visually will help you understand how air masses are producing different types of frontal boundaries and the weather associated with each. I want to kind of cut this lecture off. I know I'm going long, and I want to cut it off here. So again, I will post some videos under Chapter 9 for you to look at about the different types of fronts. I did the best I could with the amount of time here. I try to keep these talks under 12 minutes because I know that's a long time to listen to anybody on YouTube with these audio lectures. So I'm going to cut Chapter 9 off. I hope I did a decent job of helping explain the chapter, and we will be moving on to Chapter 10, which is mid-latitude cyclones.